In this video, we'll be discussing bubble sort algorithm. This is the simplest sorting algorithm we have. Okay. So we have an array of length 5 and its element are 2, 11, 9, 5 and 7. So it's obviously unsorted array and we have to sort it using bubble sort algorithm. So we'll say the current element is 2 and the next element will refer it as next, whichever element comes next to the current element. So in this case it's 11. So we'll start with checking, is our current element greater than the next element? No, it's not. If it's not, it's going to remain there. Now our current element becomes 11 and our next element is 9. So is our current element greater than the next element? Is 11 greater than 9? Yes, it is. So the element gets bubbled up. 11 gets bubbled up and it's swapped with 9. Now our current element becomes 11. So is 11 greater than 5? Yes, it is. So we'll swap it and 11 gets bubbled up. Is 11 greater than 7? Yes, it is. So it's swapped and 11 gets bubbled up. So we'll start checking from 0th element till n-1th element and check if the current element is greater than the next element, then we'll swap it, otherwise we'll leave it. And at the end, we'll have the largest number at the end of the array. So it's at its place. This thing is sorted. Okay, so now we'll have the pass will increment to 1. So in pass number 1, what we are going to do is that we already know that this thing is sorted. Okay, so rather than doing n-1, our current element, taking current element from 0 to n-1, we are going to take our current element till here, right? And our next element will be 7, because we already know that this thing is already sorted. So n-1 minus p, which is our pass in this case will be 1, right? So we'll start from 0 and check, is our current element greater than the next element? No, it's not. So it's at same place. Is our current element greater than the next element? Yes, it is. So 9 gets bubbled up. So we are bubbling up the largest number, 9. So again we'll check, is our current element greater than the next element? Yes, it is. So we'll bubble up. And now we will stop, because we are at our n minus I minus 1, n minus I minus p position, which is here. Our current element stops here in this pass. So now what we know is this thing is already sorted. So we are not concerned about this. So our next element, this will be our last current element for the next iteration, right? Because everything here is sorted. Okay, so our pass will increment again. So pass 2. And we'll check if current element is greater than next element. No, it's not. Will not swap. Is our current element greater than the next element? No, it's not. Will not swap. Okay, and we stop here. Since we had no swap in this pass, in this iteration, we can say that this array is already sorted. Okay, so we can keep track and we can check that if in any pass we had no swaps, we can break out of our loop and we can print our array, because that array is going to be sorted. Okay, so we have this sorted array. Okay, so this was the unsorted array. In our first pass that we called pass 0, 11 got bubbled up and it was placed at its place. Then in second pass that we called pass number 1, 9 also got bubbled up, the second largest number, and it was placed in the second last element. And every other element was already sorted, so we did not go further and we broke out of the loop. Since there was no swap, we broke out of the loop and we printed the array. Okay, so let's discuss a little about how it performs, the bubble sort algorithm. Best time complexity is O of n. So when this array is already sorted, we have to just check O of n, right? So we just check, is it larger than this? No, it's not. No, it's not. No, it's not. So we have no swap in this pass. So whenever we have no swap, we break out of the loop and we print the answer. So we just needed to check n elements. So best time complexity is O of n when the array is already sorted. Worst time complexity, when the array is reverse sorted, then we'll have to check O of n square time. And average time complexity is again O of n square time. And as we saw that we did not need any extra space, so auxiliary space needed is constant. Okay, and that is why we say sorting in place. So this is in place sorting algorithm. And we also say that bubble sort is stable sorting algorithm. And why? Let's see. Okay, so sorting algorithm is called to be bubbled when we have keys of same value, and when we sort the array, their original order of appearance remains preserved. Then we say that it's stable sorting algorithm. And to explain it further, I would say if this red 5 remains before the yellow 5 even after the array is sorted, then such kind of sorting algorithm would be a stable sorting algorithm. So let's check if bubble sort is a stable sorting algorithm or not. Okay, so 11 is greater than 5, so we bubble it up. 11 is greater than 9, we bubble it up. 11 is greater than 5, we bubble it up. 11 is greater than 2, we again bubble it up. Okay, so now 11 is already fixed. 5 is greater than 9, no it's not, so it remains. 9 is greater than 5, we bubble it up and swap. Again 9 is greater than 2, we bubble it up and 9 is at its place. 5, no it's not. 5, yes it is, so we swap. 5 is greater than 2. Again in the next pass we check, yes 5 is greater than 2, so we bubble it up and 5 is at its place. In next iteration we see 2 is not greater than it, so again it remains at its place, and everything else is at its place, so we say that it's already sorted. So the interesting thing is this red 5 remains before the yellow 5 even after the array gets sorted. So the original relative order of the keys with same value remains the same even after the array gets sorted. So such kind of algorithm is called stable sorting algorithm. So bubble sort is a stable sorting algorithm. Okay, so let's code it. So let's take an array and a list, and it would be a integer list. Okay, and length of the array be n. Okay, so for pass in range it will go from 0 to n minus 1 pass. Okay, and for current in range n minus 1 minus p, right? We have already discussed why minus p, because in the first pass we are going to go till n minus 1 as a current element, for a current element. In the second pass we already know the last array is fixed, the last element of the array is already sorted, so we are going to go n minus 1 minus 1. Okay, so that's why n minus I 1 minus p. Okay, so let's say next would be current plus 1, so that will be our next element. So if our current element is greater than our next element, then we swap. Then what to? Then swap. So array of current comma array of next is, let's swap it. Okay, and we are going to flag it as true. So we have a swap. In this pass we had a swap, so swap is going to be true. Initially in each pass we are going to initialize a swap flag and initialize it as false. And in case in a pass when we are not going to have any swap, then that means that the array is already sorted, and in that case we'll break out of this for loop, and we'll print the answer whatever the array is. Okay, at the end of this for we are going to check if not swap, if there was no swap, break out of this for loop and print our array. Okay, so let's try to check it. Clear. So let's take any random input, 12, 3, 5, 90, 8 and 2. So yes, we did get a sorted array. Okay, so thank you guys for watching, and I hope this helped you. Thank you.